Good day, everyone. My name is Sarah Shamila binti Samion. On behalf of my other team members, I would like to present our research paper entitled Incorporating Resilience into the IoT-based Smart Building Architecture for EI.A 2023. The design of IoT-based smart building places great emphasis on network infrastructure and the integrations of resilience into the overall system. The research paper aims to develop a methodology that comprehensively integrates resilience into the design of IoT-based smart buildings. This method entails a comprehensive examination of network components and their interconnections, specifically emphasizing the assurance of both system resilience and energy efficiency. The paper is organized as follows. Section 1 is an introduction for smart building and challenge. Section 2 provides a review of the literature on IoT-based smart buildings. Section 3 elaborates on the fundamental aspects of resilient architecture in the context of IoT-based smart buildings. Section 4 presents a discussion of the current state of research, including related work, challenge, and effort in IoT resilience. Section 5 outlines the methodology employed to incorporate resilience into the architecture design. Finally, Section 6 concludes the study, summarize the key findings, and propose future research direction. The introduction. The primary objective of smart building is to manage energy, facilitate facilities, and enhance comfort in living spaces. According to the International Energy Agency, IEA, buildings contribute to about 1/3 of global primary energy consumptions and approximately 1/3 of total direct and indirect energy-related greenhouse gas emissions. This situation is expected to worsen with a projected 50% increase in global energy demands from buildings by 2050. In the Southeast Asia region, there is an anticipated doubling of electricity demands by 2040. This escalating energy demand, coupled with the infinite supply of conventional energy reserve, underscore the need for a concerted global effort to address these challenges. An initiative proposed on November 30, 2016 involved updating the energy performance of building directive EPBD to encourage the adoption of smart technology in building and monitor their energy performance across Europe. Therefore, it is crucial to design buildings with resilient infrastructure capable of adapting to environmental changes. In achieving of this goal, the deployment of the IoT is essential. However, the challenge lies in the diverse and expanding array of devices in the IoT environments, requiring a resilient architecture that can perform intelligent search, efficient data recovery, reliable failure detection, implement security measures, and facilitate dynamic and autonomous network maintenance. The IoT architecture layer, acting as the foundational framework for the IoT infrastructure, enable the seamless integration of various systems and technologies. This integration contributes to the improved efficiency and effectiveness of the smart building ecosystems. Numerous studies have been conducted based on the IoT architecture, particularly to achieve the goals of smart buildings, as shown in the slide. From this study, it can be concluded that two key elements are essential for building to become smart. That is, automation through a building management system, BMS, and connectivity facilitated by network infrastructure. To propose the method, it is essential to clarify the meaning and fundamentals of resilience. The researcher has defined resilience as follows, among others, with the similar meaning and intentions. Number one is capability to resist external perturbance and internal failure, to recover and enter stable states, and also to adapt its structure and behavior to constant change. It also an ability to resist the degree of movement towards impaired service while maintaining an acceptable level of service and mitigating the impact of challenges that can disrupt normal network operations. With resilient architecture, it will enhance flexibility and adaptability and optimizing energy use based on real-time data. Several specific solutions have been explored to tackle the complexity of IoT-based resilient architecture in different forms, focusing on enhancing its robustness and adaptability for effective implementation in diverse contexts. Here, we discuss related work on challenges and effort in IoT resilience. While many works on resilience have been explored, they primarily focus on network in general and IoT network in broad areas, not specifically on the same building network infrastructure. Some studies had some study address resilience in the IoT-based smart building domain, but they predominantly focus on big data management and security. Therefore, there is a need to formulate a method to integrate resilience into IoT-based smart building infrastructure with a specific emphasis on connectivity. These sections present the proposed method for integrating resilience into the design. To create a resilient IoT smart building network, the study will employ the design science research DSR methodology, which include steps such as problem identification in the IoT environments, where the IoT system in smart building consists of BMS, EMS, HVAC, storage, and many more. Second is on the design and development. Okay. Under this phase, the IoT activities or IoT process and their interdependencies in redundant connections will be monitored. This is include the sensors and actuator, gateway, and also the links. Next phase is evaluating the outcome and reflections on the process. Under this third and fourth phase, resiliency analysis will be examined. This include identifying strengths and weaknesses, rank the IoT activities, and do the evaluations of the performance, and lastly, making improvement for the reflections. To achieve from the first phase until the fourth phase, we will also check on the requirement and objective by analyzing various scenarios and set the objective for solutions, and then determine the resilience factors by looking at the matrices. The resilience analysis process commences with the definition of matrix parameters. The research will focus on two important matrices: betweenness centrality, BC, and closeness centrality, CC, which are commonly used to analyze network resilience and robustness. This tool is a resilience matrix where BC identifies nodes that have a crucial roles in maintaining efficient communication across the network. If these nodes become inaccessible, it can severely disrupt network traffic. In contrast, CC measures how fast a network can connect to all other nodes in the network. Nodes with low CC are closely connected to others, facilitating rapid information disseminations. Nodes with high CC, in the other hand, helps in quickly spreading information during emergencies or component failures, ensuring that critical data reaches its destination promptly. These two matrices were selected because IoT node activities are interdependent on each other and on the network links. Therefore, BC and CC are suitable for evaluating IoT networks performance and availability. Subsequently, after establishing this resilience matrix, the study proceeds to the resiliency assessment phase. During this stage, IoT activities or also the services will be identified and controlled disruption are introduced to evaluate the strengths and weaknesses of the proposed design. This process contributes to the formulation of a resilience strategy, a key step in the subsequent phase of analysis known as resiliency enhancement. In the resiliency enhancement phase, IoT activities are ranked to assess their impact on resiliency. To facilitate this analysis, 3 levels of ranking has been identified. This level include connected component analysis. The second rank is to check on the end-to-end path analysis. And the last one is on the traffic management analysis. In evaluating the performance, evaluation criteria EC can be employed. These criteria serve as guideline for assessing the performance and effectiveness of the design system. In the context of this study, a total of 4 specific criteria has been carefully identified and chosen. With the goal of achieving efficacy, the criteria encompasses efficiency, reliability, functionality, and robustness. These criteria were selected primarily due to their direct relevance to the research objective. As a conclusions for this paper, the paper solely aims to introduce a method for integrating resilience into the architecture of IoT-based smart building by employing a resilience strategy. The paper did not discuss the experiment of IoT activities in assessing their impact on resilience. The experiment and performance analysis can be conducted through techniques like graph-based modeling, mathematical calculation, and simulations. This method provides a comprehensive understanding of the network behavior, aiding in the development of an efficient and resilient design. For the future work, in this field, it should focus on proposing a comprehensive reference architecture that specifically addresses the resilience requirement of IoT-based smart building that should provide clear guidelines and implementation strategies for integrating resilient features into the system design, unique characteristic of smart building. With that, thank you very much. And this is our team. If you have any questions with regards to the paper, you can contact me or anyone of us. Okay, for me, you can contact at sarah@unitan.edu.my. Thank you.